Hi, I'm Dr. Janet Shiver from Central Washington University, and today we're going to be talking about quadratic functions. All right, we're going to do a quick review of what you probably already know about quadratics. All right, a quadratic function is a polynomial function of degree 2, meaning the highest power on your variable x here is the second power. The general form for your quadratic is f of x equals ax squared plus bx plus c. And of course, a can't be 0 because if a were 0, we've got another linear function on our hands. So a has to be a number other than 0. If you'll remember from the past, the graph of a quadratic function is a U-shaped curve that we call a parabola. This curve is symmetric about a vertical line called the axis of symmetry, and you can see it here in my graph as this dotted line. Now what I want you to notice about these parabolas is that you have two different parabolas. One is concave up, the other is concave down. What controls that, or the way I can tell whether or not my parabola is going to be concave up or concave down, is by the letter A. The leading coefficient A tells me whether it's up or down. If A happens to be a number bigger than 0, or in other words positive, my parabola is going to be concave up. If A is less than 0, or in other words negative, my parabola is going to be concave down. Now looking at our parabolas, I want you to notice that this axis of symmetry passes directly through this center point right here. It splits the parabola into two congruent pieces, symmetric about that line. That means that this axis of symmetry is passing through either the lowest point on my parabola or the highest point on my parabola. And that's important. We call this minimum or the maximum the vertex, that low-high point. So what we're going to do today is we're going to figure out how do we find that vertex. All right, the first method for finding the vertex is through completing the square, which you've probably learned about in the past. All right, so let's take a look at how to complete the square and kind of remind you of that process. I'm going to start with just reviewing how to multiply a binomial. Let's take the problem x plus 3 squared. As you know, x plus 3 squared means x plus 3 times x plus 3. All right, over here, though, we're going to look at it geometrically. Why do we call this exponent squared? Well, because geometrically, something with sides of dimensions that are the same will create a square. So let's take a look at what that looks like. All right, in the past, you've already been able to figure out using your distributive property that when I multiply these out, x times x gives me my x squared, x times 3 is 3x plus 9. And then we simplify it, x squared plus 6x plus 9. But what I want you to see is what it looks like geometrically. All right, so let's take a look over here. If I split one side of my square into length x plus 3, this length here being x, this length here being 3 units, and then I do the same thing for the other side of my square, x plus 3. Then when I multiply these out, I'm going to have a square. All right, as we know, x times x gives us the x squared. 3 times x, here's that second number right here, is 3x. X times 3 down here is going to give us that second 3x, and then of course 9 in the corner here. So when I complete my square, when I multiply this out, I end up with a square. All right, that's going to be important when we go to complete the squares, understanding geometrically what's going on. So let's look at a problem where we complete the square. We'll keep this other guy in mind too as we go. All right, I'm going to take the polynomial, the quadratic function, x squared minus 8x plus 1. You can take a minute if you'd like to see whether or not that factors. I think you're going to be a little disappointed though. So what we're going to do with this problem is we're going to complete the square, and while completing the square, we're going to be able to figure out where that vertex is, where that vertex lies. All right, so here we go. The first step to completing the square is to get this constant, this 1, out of the way. And all we're really going to do is just slide him over. Just get him away from the other two. Okay? Then we're going to go over here to our square. Notice again, you guys, from what we just did, that x squared term comes from this top box. So I've got another x squared, so I'm going to fill in this top box as x times x, or x squared. All right, so that takes care of that. Now this middle term, which up here was 6x, and it got split into 3x and 3x. So this middle term, we have to put half of it here and half of it here. So we're going to split 8x, negative 8x, in half. And I'm going to place negative 4x in each box. All right, well, how do I get negative 4x? Well, this length already is x, so this length right here must be negative 4. So I'm going to multiply negative 4 times x to create these negative 4x's. All right, so now I can see that I've got almost all of my square, and to get it, I'm going to have x minus 4 times x minus 4. This last box right here, if you remember from the problem above, is created by multiplying 3 times 3. So down here, we're going to multiply negative 4 times negative 4 to get our 16. All right, we have completed the square. We have completed a square. Now, problem is, this x squared is already in the problem. This negative 8x is already in the problem, but I don't have a 16. So what you're going to do is you're going to add this 16 into the problem so that you can have this perfect square. You know from previous math classes, you are not allowed to just add 16 anytime you feel like it. But you are allowed to add the identity. All right, the identity for addition, of course, is 0. I can add 0 anytime I want. But what we're going to do here is we're going to add a very sneaky 0. This 0 is going to involve 16. So I'm going to add positive 16 to this part of my function and negative 16 to this 1 that we separated off by itself, giving me, of course, 16 minus 16, which is really just 0. From here, I just finish out the problem by factoring this, but if I've drawn the square, I already know what it's going to be, x minus 4 squared, and then adding these two. All right, giving me f of x equals x minus 4 squared minus 15. Now, this is nice. If you'll think back to when you first learned to graph a quadratic, when you put that original parent function y equals x squared, the vertex was at 0, 0. Now that I've written it in what I like to call vertex form, I can see the vertex has moved. Using your transformations, x minus 4 tells me that this parabola has been shifted 4 to the right. Minus 15 tells me that this parabola has been shifted down 15. So if I've gone from 0, 0, right 4, and down 15, I now have a vertex at 4, negative 15. All right, and because I know from the previous picture I just looked at that axis of symmetry always passes through the vertex, all I've got to do is look at my vertex and my axis of symmetry would pass through x equal to 4. All right, we're going to look at one more. There's one more thing you must be aware of when you're completing the square. To use this process, your x squared, your leading coefficient in front of the x squared, has to be 1. If it's not, you're going to have to start the problem by dividing everything by the leading coefficient. There are several different ways to do this, and your teacher may show you another one. My preference is just to divide everything by that number. So I'm going to begin my problem by dividing everything by negative 2. From here, we're going to repeat the process we just did. Move the negative 5 halves out of the way, slide him over. All right, then to complete my square, To get the x squared, of course, I'm going to have x times x to get x squared. And then we took half of the middle term and we placed it here and here. Half of 3/2 is 3/4, negative 3/4. So let's take a look at that. All right, so I've finished most of my square simply by placing my x squared here, taking half of this middle term here and here. To get this final box, though, the number that you're going to add, you have to square that negative 3/4. Negative 3/4 times negative 3/4 is going to give me, oops, let's get rid of that. It's going to give me, if I can get my button to work, there we go, 9/16. All right, remember though, 9/16 is a new number that you're introducing, so you add it to the first part and subtract it from here. This we know factors now to x minus 3/4, and here we're just going to find a common denominator and add. Okay, and I don't know why that ended up way down there. Let's try again. There we go. No. All right, there you go. So here we're going to add and we get negative 49/16. And then don't forget, you still have divided by 2, negative 2. So make sure that you multiply through by that negative 2. Okay? And the last step, of course, is you can do a little canceling here and you end up with 49/8. That's one way to complete the square. Now, from here, I can clearly look at this problem and tell you the vertex now is at positive 3/4, comma, 49/8. Not the prettiest vertex, but we can find it. The axis of symmetry, of course, is at x equal to 3/4. All right, that's one way to find your vertex and axis of symmetry. All right, a second way is to use what we call the axis of symmetry formula. But before we can use it, we've got to see where it comes from. So what we're going to do with this part is we're going to take the idea that this axis of symmetry lies directly between your two x-intercepts right here. Okay, right in between. So you guys have learned a long time ago to find the x-intercepts or roots. To find your roots, you can use the quadratic equation. All right, so we can find our roots by using negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, well, if I want to find something in the middle of those two roots, I'm going to add the two roots together and divide by 2. Just exactly the same way you'd find the middle of something else. So let's do that. Let's take, this time our x is going to be our axis of symmetry. So it'll be a little bit, we're fudging here with the same variable. All right, so we're going to take and we're going to add negative b plus the square root of b squared minus 4ac over 2a. And we're going to add that to negative b minus the square root of b squared minus 4ac all over 2a. And then to find the middle, we divide it by 2. Okay, if you will notice, we already have a common denominator, so I'm just going to combine these two. Negative b plus the square root of b squared minus 4ac plus negative b minus the square root of b squared minus 4ac all over 2a. And then don't forget to divide by 2. What's nice about this, you'll notice, you guys, is that these square roots cancel, and I'm simply left with negative 2b over 2a